In this example, we want to see how we can expand a memory or how to construct a memory using a given, let's say, memory units or memory ICs. And we want to determine how many of them we need, how many address lines, how many data lines, and so on and so forth. So basically what we want to construct is a memory with the width of 4-byte words. And the total capacity of the memory that you want to have is given as 2 megabits. Okay? So this is what we have. Now let's go through the questions one by one. The first one is asking how many 2K by 8 RAM chips are needed. So let's see what we get with each one of those chips in terms of the capacity. With a single chip, we have 2K by 8 memory cells, let's say. 2K by 8 is equal to 2 times 2 to the power of 10 times 2 to the power of 3, which will give us 2 to the power of 14. So this is the capacity of one memory IC of the given size. And now we want to have the capacity of 2 megabytes. The capacity that we want to have is 2 megabits. I'm sorry, it's 2 megabits indeed. So we have 2 times 2 to the power of 20, which is 2 to the power of 21. So this is what we want to have, and this is what we have from a single memory IC. So the number of the chips that we want to have could be obtained by dividing these two with each other. So 2 to the power of 21 divided by 2 to the power of 14 will give us 2 to the power of 7, which is 128. So in total, we need 128 number of chips of 2K by 8 RAMs in order to construct the memory with the given capacity. Now the next question is about the number of the address lines which are needed for the memory. So we know the total capacity, 2 megabits or 2 to the power of 21. We know the width of each element, 4-byte words. 4-byte words means that the width that we have for our memory will be in the form of 4 times 8 number of bits, or 2 to the power of 2 by 2 to the power of 3, or 2 to the power of 5, which is 32 bits. We know the width for each word, we know the total capacity. If we divide the total capacity, 2 to the power of 21, by the width, which is 2 to the power of 5, we will get 2 to the power of 16, which is the number of the elements. Number of memory elements. In order to address 2 to the power of 16 number of elements, we can use 16 lines for the address. Yeah? With 16 lines of the address, if we feed it to our memory chip, just a second, yeah, we will see how to do that. Yeah, we need to have 16 number of the address lines. With these 16 number of the address lines, we will be able to reach any of the memory elements that we have in our system. So in total, we will have 16 number of address lines. 16 address lines. And then the next question is about how many of these address lines are connected to the address inputs of the RAM chips. So we can look at the RAM chips that we have. Each RAM chip that we have is in the form of 2K by 8. So 2K by 8 RAM. It means that we have 2 times 2 to the power of 10 by 8 RAM chips, which is 2 to the power of 11 by 8 RAM chip. It means that each RAM chip has 2 to the power of 11 elements. In order to access them, we would use 11 address lines. So we can see that out of the 16 address lines that we need in total, 11 of them will be connected, let's say, to the address inputs of the RAM chips. So the answer here is 11. The next question is how many of these address lines will be used to select the appropriate chip or chips. I think the solution is obvious. We have 16 in total. 11 of them are going to be connected to the address inputs of the chips, and therefore 16 minus 11, or 5 lines, will be used in order to select the appropriate chips. And the next question is regarding the size of the decoder. What size of decoder we need? We are going to use 5 address lines. 5 address lines to refer to the chips. We would need to use 5 to 32-bit 32-line decoder. We will get 32 outputs from the decoder. So the size of the decoder will be 5 to 32 decoder. And this also would mean that in our block diagram for the required memory that we are going to build, we will have 32 rows. So our matrix will have 32 rows. The number of the columns could be obtained by looking at this. We are going to have 4-byte words, and the width of the memory elements that we are going to use is 8 bits. So 4-byte means that 4 times 8 divided by 8, we will have 4 number of columns, as you can see it over here. So we have it in the form of a matrix with 32 rows and 4 columns. And this will give us in total the number of the chips that we need to have. How many chips you want to have? We will have 128 number of 2K by 8 RAM chips. 2K by 8 RAM chips. Okay, I hope it is clear. So out of, again, the 16 address lines that we have, 5 of them will be connected to the 5 to 22 line decoder. 1 of them will be connected directly to the address input of all the chips, so they all will be connected to each other. And then the chip selects for each row will be also connected to each other. And they will be connected to one output of the decoder that we have. In terms of the data, in total we will have 32 bits for our data, for the data input. They will be divided into 4 parts. Each one of them will have 8 bits. And then they will be connected to the data input of the ICs at each column. So I assume that this is data input, and we will do similarly for the next columns. And also in terms of the output data, our output data will have 32 bits output data, and it will be combined. It will be obtained by combining data outputs from each column in this. So each one of them will have 8 lines, and they are obtained by connecting the data out at each column. Obviously they are in the form of 3-state bus, so we can connect them to each other, and you can see how it is performed. We already had examples of doing this indeed, yeah. So in this example you can see how we can determine the number of the of the memory chips that we need, the number in terms of the number of the rows, the number of columns, how we determine the number of the address lines, the number of the data lines, and so on and so forth. I think we answered all the questions. Yeah. How many address lines? We already know. How many of these address lines are connected to the address inputs of the RAM chips? How many of these address lines? That's also answered, and this one is also answered. So this means that we are done with this example. Later you can also have a look at the solution provided in the next slides. It's basically the same thing as I explained, and you will see over there how to calculate the required numbers as well.